The useful energy is kinetic energy. Why? Because a car was designed to move people from one place to another. So you need kinetic energy. If not, the people in the car cannot get to their destination. However, the sound energy, due to the grinding parts of the machine or the wheels or the metal parts, okay, that is wasted. Why? Because energy that is converted to sound energy, some of it is useless. You don't need to design a car so that it sounds good, right? I mean, it's a waste of the whole objective of a car is to get people from one point to another. So the sound is really wasted. All right, unless of course you are talking about the sound due to the car radio, then in this case, this sound energy would be useful because while you're driving, you want to have the radio on. Okay, but in this case here, the sound energy that is due to the grinding parts of the engine or the moving wheels, that is wasted. Okay, now another wasted energy would be heat energy. Okay, friction causes, all right, the grinding parts to heat up, and the engine, if you touch it at the end of the trip, it will always be warm. So this heat energy is really wasted energy. It's like a byproduct. The whole intention of the car is to move people from one place to another. Sound energy and heat energy are the byproducts. You don't need it, but it has to be there. So basically, it's wasted energy. The more efficient the car is, the more kinetic energy it possesses, and the less sound and heat energy generated. All right, so engines, as designed, as people get more advanced in technology, all right, better engines are designed so that there will be less wasted sound and heat energy, and more useful energy like kinetic energy. All right, now the other examples are for you to try out. Okay, do it in your own time, but remember that this concept is that energy can be converted from one form to another. All right. Okay, now let's move on to this next topic, next section on non-renewable sources of energy. All right. So some of these include coal, natural gas, crude oil. Okay, they are non-renewable because they come from a finite source. Okay, and this source will definitely run out over time. Okay, or it will be too expensive, all right, to get to it. For example, like oil. Okay, now how does this come about? Let's have a quick look at this. Okay, non-renewable sources come out from the ground as liquid gases or solids. Okay, commonly we rely a lot on crude oil. Okay, it is the only natural liquid commercial fossil fuel. Natural gas and propane are normally gases, and coal is a solid. Okay, these are non-renewable energy. And recently, okay, nuclear energy has been quite a hot topic. All right, nuclear energy basically is from uranium ore, a solid over here. All right, it is mined and it is then converted into fuel. It's good to note that uranium is not a fossil fuel. Okay, uranium is a very, very massive atom. Okay, that basically when it breaks down into smaller, simpler atoms, it basically gives off a lot of energy, and this energy, okay, is used, of course, in place of fossil fuel. Okay, so let's have a quick look at the different types of these fossil fuels. So the first one is how was oil formed? Okay, to understand why it is non-renewable, we have to understand how it basically is created. Okay, many millions of years ago, 300 to 400 million years ago, all right, there were many animals in the sea, fishes and all that, and you know, as time went on, they died and they fell onto the seabed. Okay, and well, we are talking about millions of years, right? Hundreds of millions of years. So there would be maybe earthquakes, right? Plate tectonic theory says that the movement of the earth. So sometimes even under the sea you have movement of earth. Okay, the seabed also moves, so sand maybe accumulates. So all of these remains that have fallen are basically covered by sand and silt. And in terms of millions of years, you can imagine, all right, that the remains that are covered by layers and layers of sand and silt and rock, okay, basically they are under very high pressure, because look at how much stuff is above them, so they are being compressed. All right, the dead animals here, the body is compressed and they decompose. And when they decompose, basically they form oil and sometimes gas is deposited. And to get to this, we need to dig, okay, very deeply into the ground, all the way until we find oil. And when our pipes go all the way down, okay, and enters an oil well, what happens is the high amount of pressure at the bottom will push the oil up. So you will find it, it's quite an exciting experience to see the drill going all the way down. Nothing happens, and wham, it hits all well, and suddenly a huge gas, a gust of oil spurts out. All right, and that is basically, they used to call oil black gold. Once you hit oil, you can make lots of money. Okay, so well, when we get this kind of oil from the ground, okay, we can get it from it's called crude oil. All right, at its very core, you can see that it's very hard to use. Why? Because it's smelly, yellow to black liquid, and is usually found underground areas called reservoirs. Okay, and these are the top 5 producing countries, therefore they are also very rich countries. Unfortunately, Iran is supposed to be a rich country, but sometimes politics, and Russia, for example, politics can play a role to destroy the wealth of a nation. Okay, so here you can see some quick. Now, the important thing about crude oil is, look at how many useful products we can get out from crude oil. Okay, you can see over here by the color coding. All right, 19.15% of it is gasoline. We use it for cars. 9.21% is diesel. This is used for public transport like our taxis and even our bus services. All right, because it's cheaper, but the oil is not so efficient as the gasoline at the bottom. And over here you can see this small layer here, other distillate like heating oil, like what you have in US when it's winter time. They have actually heating oil. Okay, and as you go up, you can see it gets heavier. Heavy fuel oil. All right, the green one here is jet fuel. All right, and this is used in our jet planes. LPG, whatever we burn and use in our cooking stove. All right, liquefied petroleum gases, and 7.27 are other products. Okay, now the process of it is interesting to read. You can see here, and if I show you this diagram, I'm sure you've come across this before. Previously learnt, I think in term 1, no, in term 2, under the topic separating mixtures. Okay, what you have here is a very interesting cartoon of separating mixtures via fractional distillation, if you remember. Alright, so I won't go too much into this.